say me, gonna work till I what?
The SE-E1 type motor protector. SE-E1 type motor protector relay has a contact terminal 11 and 12, which is normally close contact, and 11 and 14, which is normally open contact. Terminal 11 and 12, which is normally contact, will turn into open contact at 0.4 kilo ohm range on PTC, and it turns into close again at PTC resistance having 2.9 kilo ohms as installed on your motor coil winding. Here I have one diagram from which LN, from which we are going to supply a power on it, and the terminal 11-12 is a normally closed, and 11 and 14 is a normally open contact. So I just do this one to do a simulation and check. Here I have my motor protector SE-E1 type, from which I connected two valve holders. On the right, the blue color is connected on 11 and 14. This is normally open contact. And on the left side, I connected 11 and 14, which is normally close contact. And I have here my rheostat, from which I do connect also my multimeter on it, so we can measure the resistance, and I put here the plug on L and N for 230 volts. In here, I just want you to see how the motor protector is working. By the way, motor protector is working on principle of having a resistance. It is dependent on the resistance. Now, as you may see here, my rheostat is having only 109 ohms. Take note, 109 ohms. So by illustrating here, we will emphasize and think how this motor protector is worked with. Take note, this motor protector will open the normally closed contact 11 and 12 at 11.4 kilo ohms, and it will make or contact become close again at resistance at 2.9 kilo ohms. So in here, as you can see, I just wire like this, and I just follow the wiring diagram which was illustrated here at the back. This made by Partex, made in Turkey. I'm here on my test bench, and I'm going to plug here the socket having a 230 volts, and as you will see, this must be off and on the left must be on when the motor protector is in good condition. But as you notice here, having a flickering light on the valve on the right side, meaning the normally open contact has a chattering relay. Chattering relay meaning this contact relay is not good. So I've just remove this motor protector relay on my compressor and replace it with a new one, because normally the normally closed contact is keep closed, and the normally open is keep open at temperature resistance value at less than 2.9 kilo ohms and 11 and 12 normally close contact will be open at temperature resistance value of 11.4 kilo ohms. The higher the resistance, the higher the heat. Take note, resistance is directly proportional with temperature. So, this flickering light signifies that the motor protector relay is already kaput.
Kahit anong adjustment
So,
natin mga guys,
I need to replace
wala
it
tayong
with
reading
a new one. This
dito.
flickering
Ibig sabihin,
is a significance
kahit ang resistance ko
and
ay
one of
108
the
ohms
diagnosis
or
or
something, no?
what you call
Wala.
a hint
Hindi niya
that your motor
ina-accept yung
protector
value. Ayun, no?
is not
So,
in
merong
good
electronic
condition.
parts.
So in here I have the resistance value of the terminal from which connected on my PTC. I have 9.16 to 17 kilo ohms, and it is connected on my one compressor having a PTC resistance value of 0.15 kilo ohms. So this 0.15 kilo ohms is connected in parallel with this motor protector. The white and black is connected on the 11 and 12 for the normally close contact, and the two blue color is connected on the PTC, and the blue and brown color is connected on a 230 volt supply. As you may see on my video, I just put a little bit some theory and functionality of my motor protector relay so that you will be able to read it and review once you have time. This is my motor protector wiring configuration, and now I just connected it according to a wiring diagram, and I'm going to do a simulation test on it. So I'm going to test it, and for the meantime I just remove the compressor wires, and then after removing the compressor wires we are able to start the relays without running the compressor, because as of today what we are using now is the compressor number 2. So since I'm going to test the compressor number 1, I just make a connection from Q1114 to Q1112. I just reverse this connection from the PLC, and I'm going to press this contactor circuit breakers. Once I press, you see the contactor is engaging, meaning on this way we are able to start the compressor. For the meantime, we are not going to run the compressor number 1 because the compressor number 2 is in service. That's it, and we are successfully done a wiring connection for the motor protector, and for now my provision reefer is also working in manual mode because my PLC output is not working well. So what I did here to make my provision reefer plant working, we've just modified the wirings, remove some of the wire from the PLC output, and I connect directly the wires on my evaporator fan for meat, fish, and vegetable and dry provision, and on my expansion valve solenoid coil, which was in parallel with my evaporator, and I connect it also on my compressor. So once I connect and start compressor 1 or 2, the evaporator fan on each chamber will work. The solenoid valve on each chamber also will work. We are keeping and monitor the temperature on it. Once the temperature on each chamber is in range according to the set point value, negative 18 for meat room, negative 18 for fish room, positive 3 for vegetable room, and positive 10 for dry provision, we are individually switch off the circuit breaker on each chamber. Because my PLC not working well, I connected and do a wiring connection for my defrosting heater. This defrosting heater have a individual circuit breaker for meat, fish, and vegetable room, and I do put connection on it. So once there is ice on my chamber for meat, fish, or vegetable, I can individually switch on the defrosting heater. To do a defrost method, what I did is I individually switch off the fish, meat, vegetable, and switch off also the working compressor, doing a defrosting at least 2 times per day, 8 o'clock in the morning up to 10 o'clock in the morning, then 8 o'clock in the evening up to 10 o'clock in the evening. On this defrosting period, we are managed to keep a good temperature on our repair provision plants. That's it. I hope that you gain a better knowledge, additional knowledge on my vlogs. Please subscribe, like, and share.
Okay na! Tara! Napakaganda ng langit. Yan, ang langit.